Welcome to this presentation on electromagnetic coupling between the ionosphere and lithosphere preceding major seismic activity. This research was conducted by Vwavware Oruaode Jude et al. And published in Volume 5 Number 1, 2025, January to June 2025. Today, we will explore the key findings and contributions of this important work. Let's begin by understanding the problem this research addresses. Have you ever wondered if earthquakes can be predicted? Scientists are constantly looking for ways to understand what happens before a major earthquake strikes. One promising area of research is the connection between the Earth's surface, or lithosphere, and the ionosphere, which is a layer of charged particles in the upper atmosphere. This video is about a study that explores the electromagnetic coupling between the lithosphere and the ionosphere. This study used real-world data to investigate the relationship between the ionosphere and earthquake activity. Researchers collected information from GPS stations and magnetometers. GPS stations help measure the total electron content, or TEC, in the ionosphere, which indicates the density of electrons. Magnetometers measured electromagnetic fields on the ground. The study found some interesting connections between changes in the ionosphere and earthquakes. Out of the 30 seismic events analyzed, 12 had a magnitude of 6 or greater. These larger earthquakes showed a higher average change in TEC, about 2.75 TEC units, compared to smaller earthquakes. Smaller magnitude events had an average TEC anomaly of only 0.93 TEC units. The Pearson correlation coefficient was 0.68. These findings suggest that disturbances in the ionosphere might serve as early indicators of larger earthquakes. It is as if the Earth is giving us a subtle warning before a major event. However, it is important to remember that the correlation is not perfect, and other factors can influence the ionosphere. This research highlights the importance of studying the interaction between the Earth's atmosphere and its geological composition. In conclusion, this study provides evidence that there is a connection between the ionosphere and major seismic activity. By analyzing TEC anomalies and electromagnetic field measurements, researchers found a moderate positive correlation between ionosphere could potentially act as precursors to significant seismic events. This suggests that changes in the ionosphere could potentially act as precursors to significant seismic events.